Good morning, everyone.
Good morning, Joe. Good morning. Good morning, Joseph.
Awesome. You're awake. How was the keynote?
Very good.
Excellent. So we're here to talk about salt. We're here to talk about things doing things for us without us having to do a whole lot of work other than, getting it set up. And I guess most importantly, we're here to talk about setting that stuff up. So first off, who here has used salt? Would you guys consider yourself to be pretty comfortable with it? Yes, kind of. Who feels comfortable enough to describe salt in, say, 2 words or less? Awesome. Okay, that works. Is that yours too? Awesome. How about more functionally, what it does? There's 2 big words that I hear a whole lot, and they're not the ones that I'm going to use. Lamont.
Those would be configuration management.
Configuration management, those are the words I hear a whole lot.
Global orchestration.
Distributed execution or remote execution, what?
Global orchestration.
Global orchestration, is that thing?
Maybe.
Okay. I'm going to go for platform automation. Those are my 2 words for today. The thing that Salt is really built upon is remote execution. And with remote execution, we can do a whole lot of things, such as configuration management. There's a certain amount of monitoring that we can do. There's provisioning servers. I'm thinking about what I'm going to be talking about here, which is the event reactor. Now, I'm going to talk a little bit about the event system and about the reactor system that goes with that. And I'm going to give you guys a very common use case. In fact, people have been asking us for this for a long, long time. And as it turns out, there wasn't a whole lot to do. We just needed to get it done. And as of 9:30 last night, that's done. So awesome, huh? And I'm going to show you guys the project I put together. I've put it up on GitHub in the Salt Stack Formulas organization. It's called Ec2 Autoscale Reactor. So if you guys want to go over there and follow along or look at it later, I've got the code all up there, and I've got instructions on how to set up the code, how to set up your Salt Master, how to set up Salt Cloud, how to set up Ec2, and get everything ready to get this particular use case going. So first off, has anyone here actually used the event system in Salt? Who here has heard of the event system in Salt? Okay, we've got a few people that have heard of it, not a whole lot. So let's go back a little bit. With a standard classic Salt configuration, you have a master, and that master has minions, right? And I think it looks like most people in here are familiar with it to that point. Right now, the transport mechanism is called 0MQ. What will happen is when we send a command through the Salt master, it'll publish it in a queue. The minion will check in with the master. It will download those commands. It will do whatever it is it needs to do, and then it'll publish the results back to the Salt master. That's our basic Salt execution. Now, as it's doing those things, it has the capability to send other pieces of information along that same bus we call events. Now, those events aren't sent for everything. You can, if you want, you can have something run a command and then fire an event that describes that command. You can, if you're using the state system, which is what a lot of people are familiar with and associate with the configuration management portion, the state system fires off a lot of events. In fact, every time the state system enforces a particular configuration or something like that, it'll fire an event that describes what it's just done. Now, this event bus is available for really anyone to use. You can take your own process, your own third-party program, and hook into the event bus. It's just a socket. You import the event system, you send a message along it, and then you can actually put your own listener on the master and have it listen to yet another socket and receive those events and do something. So we have this bus available just for anyone to use. As long as the Salt master and minions are set up and authenticated, then processes on that machine can use those. Now, we talked about this for a long time, but people weren't really using it, and then we went and set up something called the reactor. Now, the reactor is that thing on the master that we've been telling people they could set up before anyway, and we just went ahead and set it up for them. When it receives an event that it knows how to handle, it looks at the tag that gets sent up with the event, It says, okay, I know this tag. I know that there's this other process that needs to do something with it, and it sends the information over to that other process. There's a chunk of data that can get sent along, and it can be a pretty hefty amount of data. We'll see some pretty big chunks as we look at this demo here. And it can take that data and do stuff with it and react by running something on the master, sending another command back down to the minion. The kind of the basic reactor type thing that I tell people about, that I like to say, this is something that most people can understand and deal with. Say we have a minion that gets low in disk space. It gets above, say, 90%. That would concern most of us if we had a server getting above 90%, right? And what do we do to solve that when we see we're running out of disk space? What's the first thing we do? DU.
Clean out temp directory.
Clean out temp. That's the first thing I do. And what's that?
Clean out logs.
Clean out logs. Anything else? Log files, or what was the other one? Core? Right. There's also, has anyone ever had, anyone here use Arch? You know how you guys can tell when somebody uses Arch?
They'll tell you.
Right. So with Arch, the package manager, it downloads packages and it puts them in the package cache, and then they just kind of stick around in the package cache for a while. And I've seen servers get up to gigabytes of cached packages, like 4 or 5 versions back of Apache and so on. Yeah.
They'll stay there till you clean up your cache.
What's that?
They'll stay there till you clean up your package cache.
Exactly. So, and these are things that they're easy to do. It's easy to clean out /temp. It's reasonably easy, and there's already programs that can do that for us. It's easy to clean out the package cache, pacman-scc, and you're done, right? For those of you that use Arch. The rest of you guys, let's see, yum, clean all. I don't know what it is on Debian, but what's that?
It sometimes cleans it all.
Yeah.
It'll leave stuff from previous versions.
Right. And there's still kind of cruft laying around from whatever program, but that's something we know how to deal with. And we know that when, in our particular environment, we might be used to it to a point where we say, okay, if this type of server starts to run out of space, there's a really good chance that all I need to do is run this process and it'll clear things up, right? So what we do is we set up, say, the salt scheduler, or we set up a cron job or whatever that monitors the disk space, Nagios, whatever. It sees that we've gone above 90%. It fires an event up to the salt master, and then a reactor catches that and sends a command back to, clear out temp or clear out the package cache or do whatever it is that we know we need to do, right? And that's a pretty basic use case. I'm going to go into a little bit more advanced use case today, and there's a lot of moving parts here, and this will kind of explain how a lot of these things kind of fit together. And not all of these moving parts are salt. In fact, only a couple of them are. But throughout all these moving parts, we've got to kind of all tie them all together. And don't worry, guys, it's documented on GitHub. So when you're done, you can go take a look at that. Okay, so first off, what we care about today is EC2, for instance. I'm using EC2 because they have an autoscaler that has the ability to send notifications when things happen, right? When it spins up a machine, it can send out a notification. When it spins down a machine, it can send out a notification. Interestingly, if you do it manually, it does not send out notifications. It's just the autoscaler that does that. But that's okay. We have the autoscaler kind of watching things for us. If we run out of disk space, we can have the autoscaler do something. If we have all of our machines that are getting the CPUs pegged, it can spin up new machines to take over for us. That sort of thing, right? The problem is, and this is a problem not just with Salt, it's a problem with Puppet, Chef, other platforms, right? There's a lot of things that when a new server becomes available, we want to know about that server. We want to have it in Nagios. We want to have it in Cacti. We want to have it known about everywhere, right? How do we know about it? Well, we can get the email from Amazon and say, oh, hey, I've got a new server. Let's go ahead and accept that from the master, right? And by that point, it's 6 o'clock in the morning. You've just woken up. Okay, I don't know how many people here are like me that answer their email at 6 o'clock in the morning. But let's say you do. And you go in there to accept the key and let that server take over. And and things have already kind of auto-corrected, and the server's been spun down, and that key hasn't actually, or that server hasn't existed for 5 hours. And it really didn't do you a whole lot of good, right? That's kind of problematic. So what we want to do is to be able to let the salt master know when a server has been created, let it know automagically so that the system can go in and react and bootstrap the server, not just spin up a server, but actually get everything on there, apply the configuration management to it, maybe run any processes that need to be run, and then when it gets auto-scaled down again, automatically remove that key from the master so we don't have keys, old keys that aren't being used anymore laying around on the master, right? So that's kind of an important use case for any scenario. Not just configuration management, but monitoring and so on. So first off, let's go through, actually I'm going to hop over to the GitHub repo here because we've got this handy little README here. So we've got some dependencies. First off, you do have to have an account on EC2. That's a given, right? You do need to have salt installed, and you should have figured out by now that develop branch. Actually, what's in the development branch is going to be in the next feature release, which is it's soon. I don't know what the date is on that. I think we've got an RC coming out pretty quick here, though. So pretty soon this will be Salt 2014.5, I guess. Do we have a number, Brett? Anyway, the next feature release. So it's not like you're going to have to wait a while. And you will need to have Salt API, and this is also a really recent version of Salt API. The important thing about Salt API is that it added webhooks. Now, who here has worked with a webhook? I see like 3 hands, 4 hands. So the rest of you guys, are you familiar with webhooks? Have you heard of them before? Here's kind of the idea. And webhooks are actually, they're everywhere. They're in GitHub, they're in EC2, they're all over the place. The idea is you have a service that calls a URL on your service or a URL on somebody else's service, whatever, that passes along some information that can kick off a command. Now, Amazon's webhooks are pretty intense because they don't just contain information about the instance. That's nice and all, but how do we know that notification, that webhook, came from Amazon, right? That's kind of a big deal. We don't want to just randomly accept emails from whomever saying that we have new instances, go ahead and accept them. And so the Amazon webhooks, they'll send along a little chunk of JSON that says, okay, I'm Amazon, you've got a new instance, here's the name of the instance, here's the ID, here's some vitals about the instance, and here's the PEM file that you can use to validate this certificate, validate this message. It goes through and gives you all the information so that you know that it came from Amazon. You can look at it and say, oh, well, I got a URL that came from not AmazonAWS.com, that's probably not valid, and throw it away. And the reactor does that. It'll throw those things away. And if it gets through and it came from the right source and the certificates check out and everything, then it passes it along to Salt. Okay? If you guys want to play around with webhooks, I recommend going over to GitHub and looking at their API because they will let you fire webhooks over and over and over again until it starts to work. And that's a lot easier than what I did while debugging this, which was destroy a machine and wait for 5 minutes for Amazon to decide that it was unhealthy and remove it from the pool and spin up another one in the pool. It's kind of a pain. So if you're wanting to play around with webhooks, that's a good place to start. And Salt API will be able to accept those webhooks. The nice thing about Salt API too, you can fire a webhook to it and it'll just accept it, and it's up to you to determine the validity of that message. Or you can also have Salt API authenticate the message. So as you pass everything over, you also pass in a username and password. Amazon doesn't support that, so we just authenticate the message itself. Okay? A few things need to be configured on the master, and I've put most of my configs in here. I haven't put them all in here because, for instance, I didn't secure Salt API. I've got TLS faults on my configuration. Don't do that, guys. You know that, right? Okay. So first thing we do is we set up Salt API. Now, Salt has what's called the external auth system, where we can say, for instance, in the case of PAM, that a user called my user has access to, first off, they have access to all the salt commands. They have access to the runner system, and they have access to the wheel system. The runner system, it's kind of like taking all your salt modules, these remote execution modules, and aggregating them together and adding some logic to them. The wheel system is something that we have to control the master itself. And you guys will see these in action here in a moment. Don't worry. And then just settings to set up the web server. We're receiving webhooks, so it makes sense we have to set up a web server, put it on a decent port, make it listen on all interfaces or whatever interfaces you configure, and so on. And then we need to set up the reactor so it knows that when a message comes in, what's going to happen with Salt API is it's going to tag it with this. It's going to tag it and say, okay, if that tag comes in, then go and read in this SLS file. Who here has worked with SLS files? A little less than half? Okay. It's going to pull in that file, and that file is going to tell it what to do. Those of you that are not raising your hands when I say things like who's worked with SLS files, who's worked with whatever, I guess the next session in here is going to be an intro to Salt, and that's a good one to listen to as well. I don't think I know the guy that's doing it. Anyway, so another important thing is when you first set up your subscription through Amazon to receive your webhooks, you're going to get a message initially that has a subscription URL, so it just doesn't start firing off webhooks to whomever. You actually have to opt in. And so you give it an email address so that when it sends that first subscription URL, it looks at it and says, okay, this is just a subscription. I can't do anything with this. Mail it over to whoever my admins are so that they can click on the subscribe link. And if it does happen to receive a message that, it looks like a valid message, but the certificate URL doesn't say Amazon AWS.com in it, for instance, then it can send you a URL or a notification saying, hey, I got an invalid webhook. You should look into it. If it gets past that point, but the certificate doesn't match up, it can send you a message on that. So it's kind of important to make sure you have your email settings set up here, right? And last but not least, we're going to be using Salt Cloud. And we've got to give Salt Cloud a couple of extra options so that the reactor knows how to talk to it. Nothing really big. I put in my provider settings. We've got to be able to log into Amazon and actually run our Salt Cloud commands. And I've changed the SSH username from the default. And so I've explicitly put it inside here. And then I've gone through and configured Salt Cloud itself, put in my provider configuration. If you guys have worked with Salt Cloud a lot, then this looks familiar to you. Okay? And if you haven't and you want to talk to me, then we can talk about it afterwards. Okay? EC2. I've got some detailed instructions in there too. Go into the EC2 system. You're going to have to create an SNS notification. Let me show you what that looks like here. You go in there and you create what's called a topic. And with those topics, these are the things that actually send off the notifications, and so you put in some subscriptions. Now, a little warning. Be careful when you put in a URL in those subscription boxes, because until you click that subscribe link, it will stay in there and not let you delete it. And come on. Really? Seriously? Anyway, there's a URL over there that has an IP address that I'm probably never going to get back. And so that subscription is just going to kind of hang around for forever. I've got a guy in here that this is my actual webhook. This is what's going to send it down to Salt. The endpoint, since you can't see it there, is going to look kind of like that there. Okay? And I've also, just because I was doing some tests, this bottom subscription that I have here is just my email address. So whenever something happens, I also get an email that describes it. And my mailbox got really full this past week, spinning stuff up and down. So once we've set up a notification with SNS, SNS, by the way, is the simple notification service, and really confusing with things that we use every day like SMS. Once you've set that up, you need to go set up a launch configuration. Now, those of you, who here has used Salt Cloud? Nobody? Okay. If you were using Salt Cloud, you would know you set up a profile that describes the machine that you're setting up. But we're not doing that because we're not spinning up the machines with Salt Cloud. Amazon is spinning them up for us. So we need to go through and describe the Amazon-specific settings. So in this case, you see we've got an AMI there. We have the instance type. I'm just using micro instances because they're cheap. The key that's going to be used to log into it, and so on. Okay. Once you have an actual launch configuration set up that describes the machines you're going to be spinning up, then you create an auto-scaling group. And I'm going to warn you guys about auto-scaling groups. This is something I found out the fun way. When you create an auto-scaling group, it activates immediately and spins up an instance. And if you're not paying attention until the next day, you're going to get billed for something. And if you happen to be testing on your own personal account instead of the company account, you're going to be out a couple of bucks. So, what's that? Reimbursement. I think I caught it like 2 hours later and it was out 17 cents. But yeah.
Check in the mail.
What's that?
Checks in the mail.
Checks in the mail. Go into Expensify, 17 cents. Need 2 signatures for that check. Okay, so we've set up our auto-scaling group here, and this guy here, the basic idea behind what I've set up is if I'm decreasing the group size, I'm going to remove an instance, and then I'm going to wait 60 seconds before doing another health check. If I'm increasing the group size, I'm just going to go up by, again, 1 instance. This is a really small group. In fact, this is so small, I think I set the group size to 1. So really what's going to happen here is when if I want to cause something to spin up, I'm going to have to delete what's already there and wait for Amazon to pick it up. Thankfully, I did set it to 60 seconds, not 300 seconds. Okay, going back up here. You see I've configured a notification. So whenever I launch, terminate, or there's problems with launching or terminating, it'll kick off a webhook and an email in my instance. And I can add whatever notifications I want in here. And let's see. You can see I've spun up a lot here too. Yeehaw. Okay. It must be in the launch configuration, but you also configured the size of the group and the minimum number of instances, the maximum number of instances, and say health checks. Actually, yeah, I'm in the auto-scaling group. So health checks, like if CPU gets above this load average or disk space gets to this point or whatever, then auto-scale up or down in order to compensate. Okay? So we clear on the Ec2 configuration so far? You guys all look tired. Is the keynote that bad? Okay. Anyone from the keynote in here? I'm not offending people. Were you giving a keynote? Oh, good. Okay. So what I'm going to do here, I'm going to go look at my instances. And I've got a guy here. I don't know if you guys can see it. This guy down here. This is my instance ID. Now, some of you guys, when you spin up instances, you might be used to giving them names. You know, Web01, Web02, Web03, whatever. And if you're spinning stuff up manually, or even if you've put together, say, a cloud map in Salt Cloud or whatever, and you've manually assigned names, you know, that's handy for knowing the services you're dealing with. We don't have that option here because we're not handling these instances ourselves. Somebody else is spinning this up for us, and they have no idea what to call it, so they just call it by the instance ID. Okay? You with me so far? That means when we hop over to our Saltmaster here, and we take a look at what we have spun up. You see I've got my master that's been accepted, and then I have, you know, that guy. I-605, you know, same guy that's down here, right? That's okay. A lot of times, if this is working properly, you're never even going to see these guys anyway. They're going to go up and down, and you'll get the bill at the end of the month, and hopefully your sales will handle the bill, and we're all good, right? Okay, so here's what we're going to do to get things started. Actually, before I do that, we better do some code diving so you guys see what we're looking at. Oops. Okay, now, those of you guys that have worked with salt states before, worked with SLS files, you're probably looking at this file and thinking it looks a little bit different because it's not on YAML. And there's no Jinja in there. And it's a different world because normally we write actually just about everything in salt and YAML. There's times where we want to add a little bit more logic to the game. And it makes a lot more sense to actually to get some logic into our reactor, for instance. So this guy's in Python. You see at the top we've got hashbang.py. That means to use the Python renderer. It's going to go through this run function. It's going to evaluate everything. And then it's going to return back a structure that Salt knows how to handle. And this is available not just in the reactor, but for salt states and everything that uses an SLS file can tie into this. So let's look at what we're doing in the back end. If we get a subscribe URL, fire off an email, right? Basic stuff. And we've got a copy of the SNS notification in there. If we get past that, then we go and we grab the certificate. We check to see that the URL ends with amazonaws.com. And if it passes that test, well, if it doesn't, it kicks off an email. We talked about that. If we get past that test, then it starts setting up everything to test out the certificate. And who here has worked with crypto? There's 3 insane people in here? Okay. It's rough, right? And so I've imported M2 crypto to go through and put together a certificate check. Check out this is an X509 that we get from Amazon. It goes and downloads that. It verifies it. And if it doesn't match, again, we kick off an email, right? We're trying to be as smart about this as possible. If it gets past that, then we're going to assume that's a valid message. And now we're going to check the message to see if it's telling us that we've launched a new machine or we've terminated a machine. Termination is easy. We kick off a command down here to the wheel system. Again, this is the thing that just controls the master. This is OK, wheel. You've got a key here. Delete it. Here's its name. The fun part is up here. If we've got launch, then it says OK. You guys remember in the master config, that ec2.autoscale section? So it pulls that in. It applies that. It's going to set this reactor equal true. Salt Cloud actually can identify that and kick out additional events for the reactor to use if you feel like it. We have a list of instances, in this case just one instance. We have the instance ID, and we kick off a command to the Cloud runner to create a machine. Now normally, Salt Cloud, when you tell it to create a machine, it makes a request to the EC2 API for the machine to be spun up. It gets data back with an instance ID. Then it takes that data and goes and it waits for the machine to become available. It waits for SSH to become available. Then it SSHs into the machine and it runs the Salt Bootstrap script, which installs Salt, lays down all the keys and everything, and then it backs out and tells you what happened. Or does anyone here have Windows servers they're managing? If you have a Windows instance on EC2 where you can open up port 445 by default, then it can also install a Windows minion for you. Unfortunately, that port's not open by default, but apparently it's not that difficult to go in and just open it and kick off a new AMI. What this is going to do, though, is it's going to say, OK, we already have an instance because we have an instance ID, so skip over the request part and just start waiting for it to become available. Then it sends that command over to the Salt runner right here, and then it kicks that out down here as I'm going to call it high data. That's not quite right, but it's close enough. And then Salt is going to take that and run with it. And this whole process takes half a second. So let's go ahead and let's do some damage. We're going to go in here. We're going to terminate a machine. Yes, terminate. And you see it shutting down over there. We'll hop back over to here to our left-hand menu and go into auto-scaling groups. And here's what we're going to see. We're going to see, there's my auto-scaling group. Click on that. Go over to my instances. And we have, down at the bottom, we have an instance that is still healthy because we haven't gotten to that 60-second health check yet. And it doesn't know that that instance doesn't even exist anymore. Okay, so while we're waiting for that, let's hop over here and see what we're looking at here. I've got the Salt Master running in the foreground here in debug mode. That's how I always run because I'm a developer. I don't expect anyone with any sanity to do that on a regular basis. Okay, and I've also got, in theory, my event listener running over here. This is available through Salt, through the GitHub. This will just tie into the socket, listen for events, and print them out for you. So we can kind of see what those events look like. And we'll see, as these events come through, we'll see what that SNS message from Amazon looks like. Okay, and this is chatty. This is one reason why you don't run it in debug mode. It does housekeeping a lot and lets you know that it's doing housekeeping. See what our instance looks like. It's still healthy. It'll take a moment. And while we're waiting for this, does anyone have any questions to this point? Oh, there we go. It's unhealthy. You guys see that? Hop back over to Salt Master, and actually, I think I have the print statements turned off in here. So let's go over here, and there's a message that came in. And we even see here, we're sending an event to delete that instance's key. If we hop over and look at, seriously? Look at Salt key, we'll see that my key has disappeared because that VM has disappeared, right? So this is kind of what the SNS message looks like. We have this whole chunk here that tells us, terminating the Ec2 instance. Here's the ID. It's going to tell us somewhere how an instance was taken as service in response to a system health check. Here's the signing cert URL down here, the signature version, the actual signature, all that fun stuff. And in just a moment, we're going to see another message come up here that says, we've spun up a new machine. And this is where it's going to get fun over in the master log. Okay, so we have our message saying we've spun up a new machine, and there's information about the machine. It went by real fast. So down at the bottom, we have, let's see. There we go. An instance was started in response to a difference between desired and actual capacity, increasing the capacity from 0 to 1. So it's gone ahead and done that. And you see this stuff going by here? Salt Cloud has already gone through, and it's got the instance ID. And right now it's waiting for the IP to become available. And since we're in debug mode, we see a whole lot of garbage about, every half seconds, we're checking for the port. We're just doing a soft port check there, try to connect to it. If it's there, we move on. And this usually stops somewhere around try number 85. Yes, I'm that used to it. What's really sad was when I was to the point where different cloud providers, I knew which try it was going to start connecting on. Amazon, Linode, and GCE are probably the fastest, and they're neck and neck. Azure is right behind there. Rackspace is just behind those. Okay, so we're almost up to 80. Oh, 74. There's our bootstrap script. It's fired along, and it's uploaded it. Now it's installing all the packages we need. It's already accepted the key. If we hop over here and check out Salt key, there's our new minion. So as soon as he's salted and ready to go, we can start throwing test pings at him. Okay, so you see it going by and putting in Jinja, putting in ZeroMQ, putting in, last but not least, Salt, all that fun stuff, right? And you can see the event bus is just loaded with data that we've processed through it as well. We strip out all the keys, public and private, so we don't fire those along the event bus. But you did see that huge, not that guy, that huge shell script there for the bootstrap. And look at that, we're done. The instance is created. We hop over here. We've actually fired off a lot of other reactors here, and they've gone past. Let's go back up there. So you see we've got query reactor, SSH ready reactor. Since we passed through that reactor true value, it knows that the reactor is handling this, and if we've broken it down into smaller steps than we've done here, then those steps can each be set up with their own reactors to respond independently. But we're done. We can hop back over to our saltmaster and do a test.ping. We can tell that we're on CentOS because we get that Ginger error. And that's a Ginger error, that's not a salt error. But yeah, our machine has come back and we can go through and do the fun stuff that we normally do. So salt this guy and package.install and vim and any other packages? Lamont? Any other? Screen? Tmux? Actually, I don't know the syntax offhand for multiple of the command line. So I'm going to punt and just install vim. I was expecting Emacs. Were you an Emacs guy? Vim-enhanced, which is on cent what you get anyway. Anyway, and that'll come back here in a moment. And if we wanted to have a lot of fun, we could put salt itself into debug mode and see all the new yum stuff go by. Okay, so this gives you kind of an idea of what's going on with the reactor system. This is a very real use case, and people have been wanting this for a long time. Oh, there we go, Vim enhanced. There's the old version, there's the new version. Yeehaw. So if you guys have questions about setting up reactors, feel free to look for me on GitHub, Twitter, IRC as TechHat. And does anyone have any questions for me? We got about 5 minutes left. Are we awake? Was I that boring? Walking back and forth like a hypnotist. Okay. Well, thanks, guys. I appreciate it.